Can you hear me? Okay, fantastic. Yeah, so I'm very happy to be here and talk to all of you. And what I would like to tell you today is first a little bit about DFINITY, but then mostly about the Internet Computer. So the foundation, the DFINITY Foundation, has been founded in 2016. We are mostly located in Switzerland, but we also have a research center in San Francisco and some people throughout the world. And in total, we are like 250 people, most of us working in technical positions, but we're also trying to ramp up our other operational divisions. Okay, so today we first look a bit into what the Internet Computer is, and then I would like to focus on how it evolves, and finally give you some numbers. Now, what do we want to achieve with the Internet Computer? If you look at the past, the early Internet pioneers imagined that the World Wide Web would be a great equalizer, and the Internet was supposed to be a place to foster freedom of data, and information should be easily discoverable and shareable. And we now want to extend this vision with computing capabilities on top of a blockchain to make it all tamper-proof. And this means that we want to make it possible to run any application on top of a blockchain and really realize the vision of a globally decentralized digital computer that is not owned by anyone, but evolves in a democratic way. And it needed a principle redesign from some of the things that have been done before. And we now built this decentralized system that can run very smart general contracts, very general smart contracts, and even host web pages or enterprise software, all on the blockchain. So you don't need anything addition for your nice front end. And all this is powered by the Internet Computer Protocol, which is responsible for coordinating nodes that sit in independent data centers. So none of the nodes that run the Internet Computer Protocol run in data centers owned by AWS and other giants. And together, these nodes run a protocol to execute smart contracts for anyone. And they do that with the help of blockchains underneath, and they guarantee that this works in the way it's supposed to, and it works fast, even in the presence of bad players. And to tell you a little bit more about the language that we use, so our smart contracts are called canisters. They combine data and code, and these canisters are hosted on the Internet Computer, and the users can talk to these canisters directly from their browsers using their mobile phone or laptops or whatever. They don't need to have a wallet or anything, so we want to have really low obstacles, and these canisters can then send stuff back to the users, but they can also talk to other canisters and therefore build very powerful and complex applications. You can write these canisters in any language that can be cross-compiled to WASM, WebAssembly. At the moment, we have development kits that support Rust, Python, and our own language, Motoko, and I know that the community is working on building a few more. Of course, one of the important questions for most projects in the space is what are the tokens that are being generated and used on this platform, and the Internet Computer is no different. So we have the Internet Computer Protocol token that is being there for 3 purposes. First of all, and I'm going to talk quite a bit about that, it's to enable participation in governance. And the second is to reward the node providers that run the nodes in these independent data centers I mentioned before. And they get rewards for providing their services. And also, if you have tokens and you lock them to participate in governance and vote on the different proposals, then you earn rewards. And last but not least, you can use the ICP token to, you can convert it into cycles, and these cycles are then used to for the execution of your smart contracts, similar to gas on Ethereum. And one of the main differences is, with respect to the cycles, is that we have a so-called reverse gas model. So it's not the user that has to pay for the smart contracts to be executed, but instead it's like a prepaid model where the Canister developer can top up the Canister with a certain amount of cycles, and they are then being used for the execution of messages that arrive at it. And of course, you can then use this to build applications where you have subscriptions, so you still have a possibility to actually make money. But it really helps the users to get started quickly. Now, how do we do all that? As I mentioned already before, we have these nodes in different data centers. And when I say we, it's really we as the Internet Computer community. So a few nodes are owned by DFINITY, but the vast majority are owned by independent node providers. And just last week, I think we onboarded a few that now also host nodes in geographic locations where we so far have been underrepresented. And one of the key ingredients that make the Internet Computer Protocol efficient is our Internet Computer Consensus Protocol. And it has some very nice properties. In particular, it ensures that nothing bad can happen, even if we don't make any assumptions on the networking conditions. And if from time to time we have good networking conditions, then we also make a lot of progress. And it's very fast and also very simple, which is important if you want to implement it in a if you want to implement it in a way that actually then also runs successfully. Another important ingredient is what we call chain key cryptography. So in order to verify that anything that has happened on the Internet Computer actually is correct, all you need is one public key, and with that you can then verify that the answers you get from the Internet Computer are correct. And this is possible thanks to threshold cryptography. I myself, I'm not a cryptographer, but we have some very strong people working on that. So if you're interested in that, please check out this paper, and there's also some more works with some more stuff in the works with respect to this. In order to really have a world computer, we need to do something about scalability. And there are some lower bounds with respect to consensus that show us that it's not possible, or it's very hard to try to agree on everything with everyone. And therefore we use sharding, and the way we do it is that we have this concept of subnet. So every canister is assigned to a subnet, and every node that participates in the Internet Computer Protocol is part of a subnet. And each of these subnets, they run their independent state machine replication, and the canisters that reside on a subnet are not restricted to only talking to other canisters on their subnet, but they can talk to all the other canisters on the internet computer. And this helps to make the whole thing scalable. And one of the subnets is special. It's the so-called network nervous system subnet, and it holds the brain of the internet computer. It has a special set of canisters. They're just normal canisters like all the other dApps that run on the internet computer. And it is a sophisticated DAO responsible for the operational governance, but also for the strategic governance. And the ICP token holders can vote with the NNS for some of rather simple decisions like, should we create another subnet? Should we replace this node in this subnet that we've seen has not been performing well with some other node? Should we change this small parameter that, for example, decides how often we do certain operations in our file system? So all these are questions that the ICP community can vote on regularly to improve the internet computer, and they're being executed immediately once they have been accepted. But also there are certain more strategic questions like, should DFINITY invest engineering effort into this problem? Or, hello community, what do you think about charging for resources in a different way in the future? But those are actually the minority. The majority are really proposals that are being executed directly and automatically without any manual involvement. And this is also how the internet computer evolves. So every week, the Internet Computer Protocol community votes on whether they want to move on to a new version. And here you can see how many releases of new versions the community has approved in the past, and this slide is a few weeks old, so actually in the meantime it's a few more. And these are not just tweaking a small parameter or something, but they can be really big changes. So for example, in the past year we have enabled our smart contracts to make HTTPS calls to any web server in the world. So now you can write a smart contract that does not need to rely on oracles that might be controlled by entities you're not so sure about. But the canisters, they can make these calls directly. And also we brought the ability to make smart contracts on the state of the Bitcoin blockchain possible. You might remember the talk by Hugo yesterday, where he said it would be great if we had the ability to sign transactions. Well, with the canisters on the internet computer, you can sign Bitcoin transactions, and a lot of people from the community are now also working on making this possible for Ethereum. And another nice feature that we released not so long ago are service nervous system, so that if you have a cool idea for an application and you would like your users to be the owners of this application and to help you decide how this should evolve and to be rewarded, for example, for referrals, etc., then it's very easy. You can use a so-called service nervous system that works actually pretty much the same way as the network nervous system, and then you don't need to worry about how to implement voting and whatnot. It will come out of the box. Now, in order to have such dramatic changes to the system, we had to overcome quite a few challenges. So first of all, we need to ensure that these nodes that run in very different parts of the world and not always have the best networking conditions, that they actually know about new versions and that they agree that now would be a good time to move from this version to the next version. And then, of course, they need to do this in a coordinated fashion, because the worst that could happen is that some nodes of a subnet decide, we still use the old version, and some others decide to use the new version, and then, because there would no longer be consensus. And so we had to figure out how we can do that. And of course, for the users, it's not nice if suddenly you get the message, the internet computer is currently upgrading, please wait and visit us again in an hour or two. No, you want this to be done as quickly as possible. So also we had to overcome quite a few system challenges to do this in a good way. And last but not least, we don't want to end up in a situation where we have some bug and we don't discover it before the release, and then what do we do? Can we roll back? How can we roll back? So all these things we had to take into account. But before I tell you a bit how we did all this, let me give you an overview of how this looks from a user perspective. So what you see here is when you enter the URL on top, you see all the proposals that are currently to be voted on. And just to remind you, this is all served directly from the blockchain. The front end for this does not reside on some traditional Web2 stack, but it's all coming from the chain directly. So we have here some proposals for adding or removing some node providers, for a change to one of the NNS canisters, for saying a new version of the of our operating system is good. So lots of different types of decisions to make. And if you click on one of them, you get more information. For example, here, there's a short summary, but also you can have a look in the GitHub directory and really look at what are the changes between the different versions, and then make a decision whether this is something you think should happen or not. And if you're too lazy or to figure this out all yourself, you can also just follow someone you trust. So for example, if you wanted to, or me myself, I follow a few of the people at DFINITY who I know personally, and I'm sure they really go over this all the time, and they check that it makes sense. So I don't verify this all myself. And the nice thing is, I then still get my my voting rewards, and we have more voting power based on trust. And this is part of a, you can view it as a liquid democracy model, where for any decision I can decide who to follow. So of course I can always follow for all decisions just one other person, but I can also say, okay, for proposals with respect to subnet management, I really trust Sasha. But for NNS governance, there I think Maria is a better person. So I can really tailor this to what I think makes sense, and I can change this at any time. So it's not like for when I elect someone for a parliament, where I can do it once and then I have to wait for 4 years or 5 years until I can elect them again, and I don't really know how they voted in between. So here, this is all open. I can check how they vote and whether it's really according to what I want. Yes. Now, I promised that I would tell you a bit about how we overcame all these challenges, and the first one is with this community voting on what should happen next. And the outcomes of these votes, they are stored in canisters, and then all the nodes in the internet computer, they can query this canister. So what's the newest version for my subnet? And once they see that this is different from the previous version, they can make a consensus decision on when to move to the next one, and really agree on the height at which they do that. And before they actually switch, they take a snapshot of the state of all the canisters, and then reboot. And when they come up, they just need to swap the partition from the old binary to the new binary, but the data stays the same. And in order to not have sleepless nights about compatibility, we have an extensive testing suite that should and actually does discover a lot of bugs. And also, when there's a question of should we make this a little bit faster, but then add a few more logic steps, then we always decide, let's keep it simple. And I think so far this has worked well. Now, I'm not going to tell you much about the numbers, just something I'm very proud of is the fact that in the last 2 years, so actually exactly 2 years ago, the Internet Computer was launched. We haven't had a single minute of ledger downtime. It's something we did not expect and are quite proud of. And also the amount of data that is stored on the Internet Computer, it's rather substantial. If you compare it to Ethereum, the whole Ethereum blockchain that you need to sync as a node is about 1 terabyte. So even though we are much younger, we have a lot of state. Then also here, I would not like to say a lot, because on most axes, most aspects, we are just, orders of magnitude better. But check it out if you're interested. And last but not least, there are a lot of cool dApps ranging from social media reimagined, then messengers on the Internet Computer, internet identity to allow you to use single sign-on without being able to be tracked, and so on. So I really encourage you to have a look there. And this ends my talk. I hope I've been able to give you a little insight of what the Internet Computer is and how we are able to move at the weekly frequency to new versions that at other blockchain platforms would be considered hard forks.